Hello, everybody. Welcome back to Creation Myths. I'm just going to make sure all the sounds and everything seems to be working okay, and then we'll get started for real. For the people here watching, welcome. If I sound okay, just let me know in the chat so I know we're good. And then everything seems good on my end, but just let me know. And then we're going to get going here. So here we go, everybody. Let's talk about this book. Welcome to Creation Myths. What we're doing tonight is a book review of the Endogenous Retrovirus Handbook by Donny B. That's standing for truth, or SFT, for those of you who don't know. I actually got the book right here. So this book came to me from a Patreon supporter. So you know who you are. Thank you. And also, how dare you? Because we got this. I got this book from a supporter. The idea being I could read the book and then review the book. So here I am, having read the book, and now we're going to review the book. That's what we're doing tonight, the Endogenous Retrovirus Handbook by Standing for Truth. So let's just get right into this. Before we get to the book itself, and I promise you plenty to talk about here, but let's just handle a little bit of background first, because we're talking tonight about herbs. Endogenous retroviruses. Okay, so what in the world is an endogenous retrovirus? An ERV is the site of a retroviral integration within the host genome. So the way retroviruses work, a little bit of background, these are viruses that when they're in their capsids, when they transmit between hosts, these are viruses that have an RNA genome. When they infect a host cell, they do this thing called reverse transcription. Right? Regular transcription is DNA to RNA. Reverse transcription is RNA to DNA. So they take their RNA genome and convert it to DNA, and then this kind of they snip the host DNA, open up a little bit, and they stick their now viral DNA into that host genome. And that insertion, that's called a provirus, right? So here we have an ERV proviral insertion with host DNA on either side, and within the virus, the provirus, you've got an LTR, long terminal repeat, on either end, and you've got your genes, your viral genes. In the middle, the big three are GAG, POL, and ENV. Doesn't matter what any of this does for tonight, but those are the big three genes in a retrovirus genome. So when this happens, and this happens, all the time, like for retroviruses, but when this happens in the germline cells specifically, these viruses, these proviruses, can then be passed on vertically to offspring, right? That's called endogenization. So now they're in the genome and they're going to transmit vertically to offspring, right? So at that point you have an ERV. Now, oftentimes when this happens, it gets broken and it can't mobilize, right? There's mutations that occur over time. So the ERV sequence now gets stuck and it can't mobilize. It can't become a virus again and transmit horizontally. It's just stuck transmitting vertically through the host genomes, right? So that's what we're dealing with when we're dealing with herbs, right? Now, herbs are phenomenal evidence for evolution. There's two main lines of evidence that we can point to when we're talking about common descent or universal common descent, right? So the two main lines of evidence, it's one, the location of specific viral insertions, right? So you can look at the human genome, the chimp genome, the gorilla genome, right? And you could see that there are shared herbs at the same location, right? You can look at the human and the chimp, they share a whole lot of herbs together. Not that many complete herbs because they break down over time, but like hundreds of thousands, like about 200,000 herbs of some form, herb-derived sequences shared between humans and chimps. Some fraction of those are also shared with gorillas, right? So you've got a lot of humans and chimps. Then you've got some fraction of that, humans, chimps, gorillas. Some fraction of that are going to be shared with humans, chimps, gorillas, orangutans, right? And you could just go up and up and up, right? And you can kind of follow the evolutionary histories and infer common ancestry and relatedness based on these shared ERV sequences. You can go one step further, though, and you can look at specific mutations within specific ERV sequences. So you might have an ERV sequence that is shared between humans, chimps, and gorillas, but the human and the chimp one have a specific mutation that is missing from the gorilla one, right? So you can infer common ancestry that way as well, and patterns of relatedness that way. The cool thing about these sequences in your genome is you can actually reconstruct phylogenies just based on the ERVs. You could ignore the rest of the genome and just check out the herb insertions that are shared between different groups, and you can reconstruct what are accurate phylogenies. So this is a figure from 1999, and obviously we have a lot more data since then, but like you could have rodents, and just by using their herb insertions, you get the rodent phylogeny, and then down here, you get the simian phylogeny using their herbs, right? So you can actually reconstruct phylogenies using just the herb sequences. It's really cool. So that's why herbs matter, and this is extremely strong evidence for the common ancestry of everything that you can plot, with herbs that are shared, right? You can do the common ancestry, and it goes back way beyond what young Earth creationists would call, kinds, right? Created kinds, biblical kinds, or baramins. So if you can show that there's common ancestry of viral insertions that go across the lines that supposedly separate the created kinds, then what you've done is you've invalidated separate creation, and you're providing very strong evidence for common ancestry, right? So that's why herbs matter, and that's why creationists need to deal with herbs in some way, or I should say young Earth creationists need an answer to herbs. So let's talk about this book. This book comes to us from Donny B, who, for those of you who don't know, is the brains behind the channel Standing for Truth, right? That's Donny B is Standing for Truth. You may know him as Standing for Truth because for a long time we didn't know his name. Everyone just called him Standing, right? So he wrote this book. Now, for those of you that are familiar with the Standing for Truth YouTube channel, the style is extremely repetitive. Within, you get long streams, and it's a lot of repetition, and then across events you get a lot of the same stuff. It's often very childish content. There's like a lot of like name calling and like silly nicknames going on there. So I'm Dodgeball Dan, for example. Cheers. I think that it's better to characterize, it's more accurate to characterize what Standing for Truth does on his channel as preaching rather than communicating science, because you get the repetition, you get the rhythm, there's like catchphrases, there's mantras that they use over and over again that you see and you start to recognize. So what he's really doing is preaching to a very specific audience while giving the impression of communicating science, but not actually doing that. There is, I think, utility to keeping an eye on channels like Standing for Truth, though, because it's, I think, at least a decent barometer of the young Earth arguments that are out there. So he doesn't, like, at least my impression, and maybe this is wrong, and if it is, somebody correct me, but my impression that Standing for Truth doesn't have like a specific young Earth model that he buys into. He kind of just, for lack of a better way of describing it, flails around and picks whatever sounds best at the time, which means you get a really good like breadth of like what is out there, even if the thing he says on one day is going to be contradicted by the thing he says like a week later. It's just like, what are the arguments out there? What can I use today that might help me out? So that's kind of where we're coming from with this book. Now, the stated purpose of this book is to refute the best arguments for evolution and specifically common ancestry based on herbs. It's right there on the cover. You could see it, right? Refuting, dismantling the best evidence for common descent, right? It's right there on the cover. So that's what we're going to do. We're going to dismantle the best evidence for common descent. So before I get into the book, let me just talk about the writing a little bit, because this book, it's about 170 pages long. There's the references at the end of each chapter, which is, I'll say, good and an improvement for a Standing for Truth book. I've read some other ones. I got a couple other ones on the shelf back there, and not having references is historically a problem. So having the references is good. There's a table of contents right at the front. So we've got a title page, we've got table of contents, and then we just go kind of right into it with well, I'll talk about what we start with in just a second. But the writing itself is not clear. It's kind of disjointed. It's not, for the length, it takes longer than it should. It's not an easy thing to kind of muddle through. Putting that aside, there are some other things I'd like to point out about the writing and the structure of this book. First, it starts with prologue. It starts with a prologue, which is an interesting choice for what is, in theory, a work of nonfiction. Prologues are what you typically find in narrative fiction, right? You start fiction, you start fantasy novels with prologues, for example, right? When you're dealing with nonfiction, typically you start with an author's note would be the appropriate for like why did I write this book? Sorry, everybody, my screen is being weird. Why did I write this book? Right? That's going to belong in an author's note rather than a prologue. Prologue, fiction. Author's note, nonfiction. In addition, you might have a foreword in a work of nonfiction. Typically, that's going to be written by somebody else, not the author of the book itself. Prologues typically not found in nonfiction. The next thing, we need paragraphs. We need paragraphs. Here's 2 pages that are kind of representative. Just wall of text, right? I really need paragraph breaks to help me make sense of this, both in terms of just like following my place on the page. Like, it's literally hard to read this when there are no paragraph breaks, but also just to break up the narrative as a visual cue for like, okay, we're moving on to a different idea now, right? When it's a wall of text like this, it comes across as like a stream of consciousness YouTube comment, which is, it's a book, right? It's not a YouTube comment. So like we need to structure it in a way that is coherent for the point we're making at any given time. And that structure is largely missing. Instead of paragraphs throughout this book, we do get to kind of break up the text a little bit. We get a lot of in-text block quotes. By the way, my screen is being weird for everybody. So what I'm seeing in my share screen is not the same as what I'm actually seeing on my PowerPoint slides. So can everyone just tell me right now, do you see the in-text block quote part? If you don't see that, let me know, because my screens are being a little weird, so I don't actually know what everybody is seeing at any given time. So just let me know if it's weird. So this is what a page looks like when it's broken up. There are not paragraphs, but there are these block quotes, and the structure of these is very consistent throughout the book, and it takes up a lot of space. So what you can see here, I'm going to start right here because this kind of shows how the whole cycle works. You've got a little introduction. This is like six lines, right? 1, 2, 3, 4, 5, 6 up here, right? You've got 6 lines of text from SFT, and then you've got a block quote, and then you've got source. Here's the full citation right there, and then more text from SFT, and then block quote, right? That's like, there's a lot of text on this page that is, don't worry about the size of it. It doesn't matter. I'm just showing you the structure of it. There's a lot of text on this page that is not from SFT, right? So you got word up here, and that's from SFT. Block quote, reference, see also. And then more text from SFT, and then block quote, reference. A little bit more text, block quote, right? The majority of this page is block quotes. You don't need to do it this way. You can either describe the finding and cite it, or you can block quote and cite it. You don't need to do both. And you don't need to have the full citation right here, because you have a reference section at the end of each chapter, which is good. You should do that. But then in the text, just say like, so-and-so 2005, and then you don't need to have the full reference there. So it's a lot longer than it needs to be and a lot wordier than it needs to be because of this structure with the block quotes. And that was annoying as you're reading it. Right, let's continue. Next thing, there are a lot of like little verbal tics in here, and they're written, but you know what I mean, verbal tics. It's just like, come on, you need an editor is really what you need. You need an editor, right? So like, this is a phrase that appears a number of times. More superior. Here it is, twice on one page, right next to each other. More superior. This is like saying more taller. Superior is to compare things. So if A is superior to B, that you're good. You don't need to say more superior. It's redundant and it doesn't make any sense, right? The other thing down here, M dashes. M dashes are not commas. And I know I'm being like petty about this, but like stuff like this is distracting and makes it harder to read and distracts from the point that the author is trying to make with the writing, right? So this page is representative, but is far from the worst offender, where we have these sentences where we should have like commas. Instead, we get M dashes throughout, right? No, comma, the properties of the ancient, right, or the herb sequences are absolutely necessary. Very vital properties, comma, but, right, it's the dashes are, that's not how they're used, but this is how they're used like throughout. So that's frustrating to me. It's also extraordinarily repetitive. I'm going to point this out again later on. I'm going to break down in a little more detail what's in each part of the book. There's just a lot. And some of the headings even point this out. It'll be like, the amazing function of herbs and herb-like elements continues. Like, well, you just had a section on this in the last chapter. You don't need another section on it. Either put it all together in one place, or just like, don't have the second part. Make your argument in one place and then move on. You don't have to like do half the argument over here and then another part of the argument over here. Okay. The last thing is that there are just a lot of digressions, a lot of tangents. It's not well organized. It feels like, so what happens is he'll be writing something. I'll show you an example of this later on, but he'll be writing something. It'll be like, and then this other thing, and it'll kind of go off and spend like a bunch of pages talking about this other thing and totally lose the thread of like whatever the paragraph was on that was leading into that section. So it'll be like, and now we're going to talk about this and another thing. And then like 4 pages later, you get around to the thing you were going to talk about. It feels like it's the author speaking verbally and just kind of stream of consciousness and kind of like going off on tangents as one does in conversation when they're speaking verbally, right? You say something and it jogs your memory and you think about something, you know, over here that you want to mention, and you do that, and then you bring it back to the whatever you were talking about. In writing, that makes it extremely hard to follow because it becomes incoherent if you're constantly jumping around between different things. In writing, you want to keep it, you know, on rails, right? Make your argument cleanly and crisply in a coherent way. That doesn't happen here. I'm going to show you examples of this as we get further into it. So that's just commenting on the writing, which again, we need editors. We need an editor for this kind of thing. Okay. So here's the structure of the book. We get 5 chapters. Chapter 1, the important details, just like background on herbs. Chapter 2 is designed diversity. So this is about like created heterozygosity and stuff in the genome has functions. Chapter 3, the non-discriminatory evidence. So this is about stuff that, hey, could work for either model. So it's going to be like nested hierarchies, even though it doesn't really work, but that's what's in there. 4 is the meaty chapters. It's like half the book. So this is where we get to created units of DNA function, the idea that herbs were created rather than inserted by viruses, and they have functions and they do things, and that's the evidence they were created. And then the conclusion, which is mercifully short, is called conclusion, common descent overturned. And I'll talk about that on the flip side. One thing I appreciate about this book right away is that it's SFT is very clear about what he intends to do. So this is what we get very early on. And I forget the page number for this because it actually spans 2 pages, but I'm going to look it up right here in my book, which is heavily annotated. I'm just going to tell you the page number that this is. So if you want, you can look it up. Here we go. It's at the bottom of page 22, 1 and 2 and 3, except for the last 2 lines there are go on to the next page. The also form a nested pattern of distribution across various organisms. That goes on to the next page. So I appreciate this part because he says, you know, in a nutshell, why do evolutionists believe herbs are a good line of evidence for common descent? The similar herbs at similar locations across different groups. Yes. Forms a nested hierarchical pattern. Yes, that is good. Number 1, check. I endorse. Number 2, the properties of the herb itself. The idea there is that herbs are from viruses, right? That they're actual viral insertions, which, like, yes, that's not really up for debate. It will be in this book, but it's not really. So 2 is fine, but it's not the point. And then 3, shared mutagenic discrepancies. Fine. Yeah, there's mutations that also reinforce that nested hierarchical pattern. Long-terminal repeats, they don't have to be in the LTRs. If it's a complete ERV, it can be anywhere in the ERV. It's just in the ERV-derived sequences. So like 3, good enough. So credit where it's due. We have what I think is an honest attempt here to present the arguments that he intends to refute. He's not, doesn't look to me like we're strawmanning here, which, good. Thank you for that. So keep these in mind as we go through and talk about this stuff, because these are the arguments that we're going to see, do we address, right? That's the question here. So let's talk about the content. I've broken this out by chapter. So we've got chapter 1, chapter 2, chapter 3, and then the whole rest is chapter 4, broken up into 3 parts. most of this is not relevant to those points I just mentioned. It's just not. It's just not relevant at all. So the background in chapter 1 is fine. There's parts that I quibble with a little bit, but like it's mostly fine. It's good enough that it's not worth spending more time on here. Let me put it that way, except for one thing that I'm going to mention briefly later. But it's mostly fine. The background information on like herbs, it's framed in a YEK framing, but like the information, it's mostly okay. All right. Then we get in chapter 2, we get all the stuff about like junk DNA, herb function, design diversity. None of that stuff matters because the argument that I make and other people make with herbs, it's about the pattern across what you would consider created kinds, not just the herbs themselves, but the mutations within the herbs. Doesn't matter if they're functional. Doesn't matter if they're, designed in place. The mutations are what they are. If the mutations are shared, then that's not happening across different lineages, right? So whether they're functional or not, just 100% doesn't matter if that's what's going on in chapter 2. Chapter 3, as I said, is the non-discriminatory evidence. It's all about like nested hierarchies and how you can get that from designed things. And it's all irrelevant, but like it's also bad. And I'll mention this briefly later on, but you get stuff like the vehicle thing where it's like cars and then things with 4 wheels and things with engines. And it's like, well, there's problems doing nested hierarchies with things that don't reproduce. But again, it's not relevant to the big picture here. So I'm going to basically ignore it so that this doesn't take 3 hours. I'm just going to focus on the parts that are actually relevant, which we're 20 minutes in, haven't gotten there yet. I promise we will. Okay, then we get to chapter 4. Now, most of chapter 4 is also irrelevant. It's super repetitive. It is super repetitive. So there's a lot of like, it's not junk DNA, it's actually functional. Like, I don't care. Why wasn't it in chapter 2? It should have been in chapter 2, right? It's a lot of that. So it's disjointed because it kind of keeps revisiting stuff that we already did. This is also where you find the attempt to deal with shared herbs, which I will talk about in just a minute. And then this little bit of blue right here. This little bit of blue right here. That's 5 pages. 5 pages out of about 170, where he does attempt to address the shared mutations and the distribution of shared mutations within herb sequences across different organisms. That is the thing that needs to be addressed. Like if you ask me, say like, Dan, name the single best argument using herbs, it's you get herbs in the same place with the same mutations, right? You get a hierarchical distribution of both of those things, the herbs and the mutations within the herbs. So like to spend 5 pages on that thing, that's the linchpin of the whole thing, I think. And it did not get the attention that I think it deserves. We'll see why that's the case later on. And then this end here, I'm going to keep that a secret for you. I'm not going to spoil that surprise yet, but suffice it to say, the end of chapter 4 is a twist ending that I did not see coming. And I hope you like it when we get there. So let's talk about these 2 arguments. First, we'll talk about shared herbs and design. Now, he spends a lot of time here arguing that herbs are actually functional. So the argument that SFT makes goes like this. Herbs are designed with functions, right? They're placed in the genome on purpose with specific functions to do specific jobs. Well, based on that, shared herbs just imply common design. Okay, that's what they do. That's the argument, right? If they're functional, they were created, and therefore sharing them is just, it's like an engineer reusing parts in a car, right? That's it. So this argument works superficially in that, like, if you make the assertion, like, a designer could just have put them all in the same place. Like, well, yeah, right. An omnipotent designer could have done that. Yeah, like superficially, yes, that works. But if you actually like look at this argument for 30 seconds, it totally falls apart. One, because herbs are from retroviruses. This is not really up for debate. There's a genetic structure that I showed you earlier that herbs have and retroviruses have, right? Where they have the LTRs on each end and then GAG, pol, and EMV in the middle. And nothing else has that. Nothing else has that. The other reason we know that herbs are from retroviruses is that there are herb insertions happening right now. Like we can look at lots of different things. So there's actually human herbs that are not in everybody in the population. They're only in some people. And it will be interesting to see. I won't be here to see it, but somebody presumably will be here to see it, as long as we don't, drive ourselves to extinction at some point. But eventually those ERVs will either become fixed in the human population, or they'll be lost, probably via drift from the human population. It'll be, one or the other. And that'll be really interesting to see. There is an explanation that he gives for the partial ones, the ones where they're like, they're in part of the population, not the whole population. He says they get lost, but it doesn't really work. It doesn't really work, because if you lose it from somebody, right, if everyone starts with it and then you lose it, you're going to lose it in a bunch of like little places, like randomly, right? And it wouldn't form like a clade of having it. But the partial ERVs, they actually form a clade, right? You could be like, oh, look, and then this group has this ERV, right? It forms a clade. And it's because there was a common ancestor with the insertion, and then it has since propagated through the population. That pattern is not what you would see if they were lost rather than acquired, right? So that's a problem. The other reason we know that ERVs are from retroviruses, and this function argument doesn't work, is that the things that they do are functions that are derived from viruses, right? So like, think about the things that ERVs do. One thing that SFT harps on a ton is that they are these like viral mimic sequences that look like viruses because they're derived from viruses, and they actually inhibit infection by viruses, which, like, yes, viruses do that, because if you're a virus, you know what you want to prevent? You want to prevent co-infection, which is I infect a cell and then another virus infects that cell. That's bad, because that other virus is going to start competing with me. I don't want that. I want to find a way to keep those viruses out. So like HIV, for example, one of the things it does when it gets into human cells is it messes with the production of the receptor that HIV uses. It actually it removes the receptors. It sequesters them inside the cell so they can't get to the surface. So over time, you lose the receptors. So additional HIV variants cannot infect that same cell, right? It's the equivalent of like, you get into a city, right? You just captured the walled city. Now you pull up the drawbridge so nobody else can get in, right? It's a way of minimizing competition as a virus. Why would such mechanisms not exist for genome integration? I integrate into the genome and I'm going to keep everybody else out of the genome. Like that's perfectly intuitive. That's exactly what I think a virus would be selected to do. That makes perfect sense. The other big one, of course, and some of you in the chat know exactly what the other big functional ERV is. It's not actually an ERV. It's a gene acquired from a virus via horizontal gene transfer. I am, of course, talking about syncytin, which is involved in embryonic implantation and placental formation during mammalian gestation, early in pregnancy. And that's super obviously something that a virus would do, because what it does is suppresses an inflammatory response, right? It suppresses the immune response, which a virus is going to suppress the immune response. That's going to be something a virus would be selected to do. That would be really good if you're a virus. If you could suppress a local immune response, it's good for you. You're going to want that. That's going to help you, right? So none of these functions that creationists point to when they're looking at ERVs, none of these are things that are like, whoa, how did it do? Like, these are all things that viruses should be doing anyway. And it's just that it's now done as part of our own physiology, right? So, I don't know what else to say about this. This is not a good argument. It doesn't work. So function does not imply design. Okay, so if you can't imply design, you can't apply shared design for shared ERVs. A better explanation is common ancestry. So now let's get to shared mutations. And I say finally, because look at the page number here. It takes that long to get to the part of the book that's relevant to this shared mutations argument, which I think is an even more powerful argument, right? Now, I actually do want to pause for a second to highlight what Andrew just said in the chat here. And if you're watching this in the future, put the chat replay on. That'll be helpful. But it's also the case that I even neglected to mention that most ERVs are so broken down they don't even have functions anymore. But it's just not really material to the argument. But it doesn't, because the function thing just doesn't matter. But most of them actually don't, right? So it just Doesn't matter, but that's the other side of it, is most of them, the physiologically don't have any impact. Okay, so let's talk about shared mutations in ERV-like sequences. So here is the description that SFT gives for this argument. They also look at the mutations within the ERV elements. For example, we find pattern of mutations within the ERV-like sequences, and this pattern is distributed hierarchically. Yeah, in other words, you can make a nested hierarchy based on the mutations within ERVs. Yes, that is extremely strong evidence for common ancestry. So that's on page 129. But then we get another digression. Page 130. Before we move on, and then we spend like a bunch of pages talking about other stuff, and it just doesn't matter. The reader may be wondering why all the information presented in the above several paragraphs are important in responding to the argument of shared mutations in LTRs that end up. Yeah, the reader was wondering that while he was reading, because all this stuff in here about like LTRs being functional, it's already been done throughout like the earlier parts of the book. We don't need to do it again. This is what I mean when I talk about like tangents and just disjointed, like, oh, we're going to go do this thing. It doesn't matter. We already talked about the fact that these things are supposedly functional. So like, great, you can just reference the other chapter. You don't have to like do it again for 5 pages, right? It feels like a verbal kind of thing where he's just like, oh, well, let me just mention this again before getting to the point. So it completely loses the thread here. So we finally get back. Let me try that again. We finally get back around to this, right? On page 135. We finally get back around to it. And here's the argument. This is it, everybody. This is the linchpin. This is that blue little 5 pages that I showed a few slides ago. One thing I want to mention is the fact that mutations are not as random as evolutionary scientists have always assumed. It is well understood that within the genome exists hotspots. Those claiming mutations are purely random are out of date on the latest research and technical literature. Mutations are not as random as proponents of common descent claim. This is the explanation for why you get shared mutations in a nested hierarchical pattern. Mutational hotspots. That's the explanation. I'm going to show you more pages, okay? Because this continues for a few pages, but here we go. Page 137. If mutations are not completely random and there exist mutational hotspots in the genome of living organisms, then shared mutations between various creatures cannot be evidence for a shared relationship. That is wrong. The most complete answer to the mutations found in ERV-like sequences that form hierarchies across various creatures, especially the great ape family, is probably a combination of both created differences, which doesn't make any sense because then we wouldn't know there were mutations, and mutational hotspots. The existence of mutational hotspots and the fact that mutations are not entirely random is most likely enough to refute this argument. That's it. That's the explanation for why you get a nested hierarchical pattern of mutations within ERVs. Hotspots, mutational hotspots. Maybe I should say, that's it? That's the explanation for why you get a nested hierarchical pattern? I don't know if this is an attempted sleight of hand or if SFT genuinely does not understand what hotspots are and how they work. But this does not fly at all. So let's talk about hotspots. Mutational hotspots in the genome are regions where mutations are more likely to occur, right? They affect where mutations are likely to occur in a probabilistic sense, right? There's nothing about hotspots and cold spots that is deterministic, right? It's all probabilistic, right? So if you have a hotspot over here, it just means mutations are more likely over here compared to over here, right? That's what we mean by hotspot. It's the relative frequency of mutations differs in different regions in the genome, okay? Hotspots do not affect which specific mutations occur, nor do they affect the order in which specific mutations occur. In order to reconstruct the nested hierarchical pattern that we see, you need to have the same mutations occurring in the same sequence, right? In the same order over time in many different lineages. That's what you would need, right? This deterministic pattern of both specific mutations and the sequence in which they occur. That's what you would need to generate in order to recreate this hierarchical pattern. Hotspots do not do that. Hotspots just tell you where mutations are more or less likely in the genome. But the specific mutations that occur are probabilistic. I was disappointed when I read that because the lead up to this book was basically, I've got a hypothesis, I've got an explanation, right? And man, this is not it. This is not good at all. So again, the word that I don't like random, because you tell someone random, they think flip a coin, heads or tails, roll a die, right? Equal probability. It's biased randomness. It's probabilistic, right? Rather than deterministic, right? That's what's going on here. Mutations within a genome are probabilistic. They're more likely to happen in some places than others. And certain types of mutations are more likely to happen than other types of mutations. But there's nothing about any of that that says this specific mutation will happen at this specific place, and then this specific mutation will happen at this specific place, and then this specific mutation will happen at this specific place. And those will all happen at approximately the same time across all these different lineages, right? Giving the illusion of common ancestry, even though it's happening independently, right? There's nothing about hotspots that lines up there, okay? So for SFT's counterargument to work, the location and the order of mutations has to be locked in. It's not. We know it's not. We know that mutations are not equally likely everywhere in the genome. We know that certain types of mutations are more likely than others. We also know that within those bounds, mutations are probabilistic, not deterministic. So you can't use mutational hotspots as an explanation for a specific pattern of mutations across different lineages. It's not more complicated than that. That's the main argument that SFT makes, and it completely fails. It's just 100% face plants. That's it. So now we get to the really bonkers ending to this book, and this is the part where my annotations in the margin for this part were something else. For this page right here, well, let me tell you what the ending is. The ending part is all about how RNA viruses actually come from herbs. And I'm going to put aside the fact that there's conflation here between RNA viruses and retroviruses, but I'm going to just chalk that up to being sloppy and not knowing or caring about the difference for the purposes of writing this book. But the hypothesis proposed at the end here is that RNA viruses come from herbs, not the other way around. This is completely absurd, but it is necessary for the YEC model to work in terms of herbs, because if herbs are actually from viruses, then forget it. Separate ancestry is totally shot, right? It doesn't work. The pattern is just too clear. So you need an alternative explanation for herbs. Well, they were created in place. Okay, what about viruses then? Oh, the viruses came from the herbs, right? Defective herbs or something. There's a lot of problems with this. But I just want to tell you that my annotations on this page that I'm highlighting here, right? He says, some creationist scientists have proposed an explanation for the origin of exogenous retroviruses as originating from healthy herb sequences. In our cells, this part is just, what? In our cells, we make all of the parts that viruses make, in that we make protein and nucleic acid. Yeah. We have all the ingredients and properties to make viruses. No, we don't. We make protein shells. No, we don't. We don't make capsid proteins. We do not make capsid proteins for viruses. We don't make envelope proteins for viruses. We don't do that. Like, there's no human gene that's equivalent to like the neuraminidase for influenza, right? It's not a thing. There's no human gene that's equivalent to like SARS coronavirus 2 spike protein. We don't make those. We don't have all the things to make viruses. This is, I don't know where this comes from, but this is just completely wrong, right? And we have DNA and RNA copying enzymes. We do. You know what we don't have? Reverse transcriptase. which you need if you're going to be a retrovirus and go from RNA to DNA. We don't have a processive reverse transcriptase that is capable of doing that. You know, okay, so this is just like wrong. And then this paragraph is just like it's just like kind of like shady, vague evidence, right? And then it sounds like viruses came from the human genome rather than from outside. This makes the most sense anyways, editor, since RNA viruses require a host to replicate, and therefore it would reason that the RNA viruses originated from within the host rather than from outside. This would appear that it had to occur this way. I don't know what. I don't know. My annotations in the I read this in hard copy first. My annotations on this section are, I'll read them to you. I'll show you. It's, I don't know if you're going to be able to see that because it's small, but it's LOL and then all in caps, LOL. Hang on, there you go. LOL, all in caps, LOL, and then that, right? Like what are we doing here? So a couple of problems here. As I mentioned earlier, there are herbs that are not fixed, not just in humans, but in other things. So you can actually show the process of integration occurring in real time. And SFT actually agrees that we can see this process happening in real time. So he says, herb elements that are unfixed in the human population could be the result of the endogenization of a retrovirus. So where he kind of comes down here is saying, and he actually makes a prediction about this, is that the herbs that are fixed are going to have functions, but the ones that are unfixed, they're only found in some fraction of the population, and whether it's for humans or other things, whatever, they are found in some fraction. Those are actual examples of endogenization. So endogenization is a process that can happen, but the vast majority of herbs and herb-like sequences were created in place with a function. Even the ones that are highly degraded, solo LTRs, transcribed at very low levels, it's all created in place for function, except for the ones that are not fixed within the population. Those are actually exhibiting this process of endogenization. Think about just like the theological implications of this argument for a second, which is not my bailiwick, but just think about this for a second. So God basically put like time bombs in the human genome that could become viruses, but then also could function to defend against the things that resulted from them. Like what? Why? I'm not one, like, I don't think well, why did God do with that? I don't think those are good, but like, this makes no sense. This makes no sense. Anyway, that's the fun twist ending, is that actually it's a whole big thing. It goes for pages about like it actually RNA viruses come from the human genome, that is a take. That is a scorching hot take. Okay, so then we get to SFT's conclusion, which is it's just straight up preaching. It hits all the high notes. Like it's not attempting to summarize the arguments. It just, if you've ever seen like an SFT live stream, it's that. It's common ancestry has been destroyed. We've dismantled it, forced into early retirement. Like it hits all this stuff. It is informative. The structure of it like that is very informative, though, in that it indicates the target audience. And it's not me, right? Not like the stated purpose is to try to address actual scientific arguments, but the way it is constructed shows that is not the actual goal, right? The actual goal, the target audience, is young Earth creationists who already agree, and it's to reassure them, right? This is a work that is designed to reassure rather than persuade, okay? So before we get to my summary for this, before we get to my wrap up, we are almost done. I do want to go through a few more things that were in here. There's just too many smaller problems to like spend a lot of time on, but I want to mention them before I'm out. If I was to spend time on each of these things, we'd be here for 2 or 3 hours. Do not have time to do it. But I do want to point out, as I'm reading this book, that it's just like, that's a problem, that's a problem, that's a problem. And I want to point them out to you, because I read and annotated this book, and darn it, I'm going to use those notes I took. So first, there's a really bad quote mine the abstract thing going on in right at chapter 1, page 12. It's a little bit, the point that Donny is trying to make is that, well, we've never seen herbs endogenized before. They all happened millions of years ago. And he takes a line from an abstract to that effect from a paper, but it's the quintessential, like, quote mine the first line of an abstract thing. And the paper actually shows, it's about koalas, and it shows endogenization in progress right now in koalas. So, like, you got to read the rest of the paper. You can't just take the first line of the abstract. I actually use that as an example in my recent creation trick, quote mine the abstract video, so I'll link that down below. There's a lot of begging the question going on in here, in particular with the design stuff and the idea that these herbs can be used as antiviral elements. So there's a lot of like forward thinking has to be designed. It's like, well, why is that? It sounds like you're just kind of asserting that for no good reason. You're just saying it's forward thinking, therefore it was forward thinking. Like, well, why was it? Why are you calling it forward thinking? So that happens kind of in a few places. There is a digression for a reason that I do not understand, but there is a section on created heterozygosity. And Donny still does not understand the argument against created heterozygosity. He goes on for a number of pages about this. He thinks it has to do with the PRDM9 sites and the rates of recombination, and he thinks it has something to do with out of Africa and the different levels of linkage equilibrium and diversity in African versus non-African populations. And like, dude, that is not the argument. For the record, the argument against created heterozygosity is that the rate of intra-exonic recombination, so the rate of recombination within the coding region of genes, right, the parts that code for amino acids, the rate of recombination in those regions in the genome is too slow, right? That's why created heterozygosity doesn't work. You can't get like the 1,000 alleles or more that we see for some human genes. There are 4 digits of alleles for some human genes. Starting with 4 alleles, no matter how different those alleles are, the recombination rate is just too slow to get all the variants that we see today. That's what the argument is. It has nothing to do with out of Africa. I don't know why this part of the book exists, but it shows that SFT does not understand like this argument at all, which is astonishing to me because I did a video on this a couple of years ago at this point. It was a couple of years ago at this point. He responded to it like, I'm going to respond to this guy's arguments. Didn't understand it then. Years later, still doesn't understand it. All right. He messes up how nested hierarchies work. This part of the book was fun. This is in that non-discriminatory evidence chapter. He has, it's on page 56 specifically. He uses, he does the nested hierarchies thing, but it's vehicles. Now, there's a problem here. One, vehicles don't reproduce, right? So like planes, trucks, cars, they don't reproduce. The other problem is his categories here, starting from smallest to largest in the nesting. I'm going to read this for you. Sedan, vehicles with 4 wheels. Okay, sedan is a subset of that. Land-based vehicles. Okay, 4 wheels are a subset of land-based vehicles. Engine-powered vehicles. Okay, fine. You know, all engine-powered, land, 4 wheels, sedans. That's a nice nested hierarchy. The highest category in the nested hierarchy, unpowered vehicles. Engine-powered vehicles is not nested within unpowered vehicles. Should be nested. I corrected it. Because at some point I just started treating this book like an essay from a student. Should be all vehicles. Should be the highest category. But we're messing up nested hierarchies, putting aside the fact that vehicles don't reproduce, so you can't use a nested hierarchy anyway. All right, so that's just like the nested hierarchy thing. I mean, he stole that from Jeanson. This is not Donny. He stole that from Nathaniel Jeanson, so blame Jeanson for that one. There is so much of this book that is just off topic. So much of this book that is repetitive. There are huge sections where my annotation is just like, why does this exist? I don't know why it exists. I don't understand. Why are we talking about this again? So like I have some of the parts listed here that are just like, why do these parts of the book exist? It's this whole section from 106 to 128. One of my annotations, he's talking about like long terminal repeats having functions, and my annotation is something to the effect of this book is made of repetitive elements. Like, it's just the whole section does not need to exist. It's just rehashing arguments from the earlier chapters, and it's super pointless. Like, who cares? Already said this. There's also a part of the book that I think just like ended in there. Did this already, exclamation point. Like, this whole section is just, did this before. This whole section is just arguments he already made, and you end up padding like 20 pages in there that don't accomplish anything. It just breaks up the narrative, makes it harder to understand what the overarching point is. He also seemingly doesn't understand how selection works, because he says if herbs were not functional, if they're just sitting there not functioning, then they would have been selected out of the population. That's not how selection works. If there's no cost to having them, or if the cost to having them is less than the cost of having 100% perfect regulation to either completely suppress them or excise them without doing any damage to the genome, if the cost to do those things is greater than the cost to just like have them, then they're just going to kick around, right? They're mostly governed by drift, so not doing anything one way or the other, unless they secondarily acquire a function, in which case we're going to select to keep them. But it's not, selection is not an all or nothing here, right? It's not we keep it or we get rid of it. It's going to affect the frequency based on, do you have 5 kids or do you have 3 kids, right? And it's like shades of gray like that. That is missing. That nuance is missing from the discussion of selection in this book. We also have a great example of citing research that refutes your claims, and I'm going to tell you all about this one because these numbers are pretty good, because Donny cites a study as kind of a gotcha here on page 86. He cites a study that they say a total, and this is, by the way, this is about like stuff is functional, like, haha, they're actually functional. Here's a study. A total of 114 of the ERV-derived transcription start sites can be demonstrated to drive transcription of 97 human genes. It's 114 of the ERV transcription start sites and 97 human genes. There are nearly 200,000 ERV-derived sites in the human genome and 20,000 protein coding genes. And we're going to say, well, look at this, 114 of the ERVs and 97 genes. Wow, they must all be functional. 114 out of nearly 200,000, 97 out of nearly 20,000. Those numbers do not support the argument that SFT thinks they support. And then the last thing on this slide here, and there's more that there's other stuff I just left off, but there's other things. It's like, where's Waldo? Go through and find your own problems. We're citing outdated research and commentary here. This is particularly egregious in a section on ENCODE around page 118, where he quotes Fuzz Rana, Dr. Rana, from Reasons to Believe. Some of you may be familiar with Dr. Rana's work. One of Dr. Rana's big things is that like junk DNA is not really a thing, and ENCODE showed that junk DNA is mostly actually functional. SFT cites at length, it quotes at length from a thing Dr. Rana wrote back in 2012, before ENCODE put out their 2014 revision, right? So ENCODE put out their big splashy, the one that everybody knows is from 2012. That was the one that made all the headline, oh, the end of junk DNA, right? 2 years later, 2014, they put out another thing, and they were much more circumspect in their conclusions in the 2014 piece. The piece that SFT uses from Dr. Rana was from between the two. So I don't know what Dr. Rana's current position is on ENCODE and junk DNA, but he was writing based on the 2012 piece that has subsequently been walked back by the same group. Now, if this book was written in 2013 or even 2014 or 2015, I could see that. It's all kind of, bang, bang, bang. It's all relatively recent, but it's 2022. Why are we citing things from 2012 rather than 2015 or 16 or 18 or 21 when it comes to junk DNA, considering that 2012 piece is considerably outdated at this point? So that's a problem. And that came off as not particularly careful or caring about the current state of the literature on that question. So let me summarize, and then I have one more quick thing after the summary. What I think is going on here is I think SFT realizes, as a young Earth creationist, that ERVs are just slam dunk evidence for common descent, right? If ERVs are actually the result of viral integrations, then like straight up common descent. Because the sites are probabilistic, the mutations that occur are probabilistic. Both of those things generate your nested hierarchies. So, like, that's just, it just screams. It's a giant billboard that screams common descent. So, as a creationist, you have to come up with an alternative. And the alternative is that they were created in place rather than being the result of viral integration. So SFT, he takes that and he claims to be addresses who needs an editor now owned. It's not good. So SFT claims to be addressing the strongest arguments for common ancestry for ERVs. I literally wrote this like a couple hours ago, and then had dinner and did bedtime for the kids. So he claims to be addressing the strongest arguments for common ancestry that you get from ERVs. But most of the book is talking about like irrelevant stuff. Most of the book is about like ERVs are functional, therefore they were put there. But that doesn't matter. When he gets to the relevant parts, the locations and the mutations within the actual ERVs, he does not do a good job addressing this evidence, and specifically, rather fantastically face plants when it comes to the shared mutations argument. Just that hotspots thing was just like, no, not at all. So what we're left with is we still don't have, and for Yex, you still need a valid counter-argument to ERVs as evidence for common descent. And I want to be 100% crystal clear here. I want to be super crystal clear. So if SFT or anybody else wants to pick up this mantle and try again, here's what you need to do. It doesn't matter if ERVs were designed. It doesn't matter if ERVs are functional. None of that stuff matters, right? We can treat ERVs as designed, placed in specific places, and 100% functional. None of that stuff is true, but we can say it is. It doesn't matter for the argument that I'm making, right? It just doesn't matter. The argument that you need to address is why across lineages in separate created kinds, you're able to recover nested hierarchies based on the polymorphisms within ERV sequences, right? It doesn't matter if they're functional, doesn't matter if they're designed. None of that stuff matters. What you need to do is explain why you can recover those nested hierarchies based on the sequences themselves. That's what you need to be able to do. Hotspots does not do that. Hotspots only tells you where you're more likely to have mutations, not which ones, not the sequence in which they occur, right? So that doesn't do it. Hotspots don't do it. You need a better explanation. All this other stuff, completely irrelevant. Most of this book, it's 170 pages, probably 150 pages of this book, not relevant. 140. Let's be generous and say 30 of them are relevant. Most of this book, not relevant to the actual question. And when he does get to the part that's relevant, doesn't do a good job at all. Just does not have, a model, a hypothesis, any idea of like a coherent idea that jives with the evidence that like does a better job of explaining this than common ancestry and isn't directly contradicted by evidence, that we see there. Okay, that's what we need. So that is my review of the Endogenous Retrovirus Handbook by Donny B, aka Standing for Truth. Now, I have one more fun thing to talk about. The last thing is that this book was kind of my fault a little bit, maybe. So what happened is I had a conversation with Dr. Charles Jackson a couple months back, talking about the evidence for common versus separate ancestry. It's a really good conversation. I'll link it below. That conversation ended up mostly being about ERVs. We talked about a lot of what I just talked about here, shared sequences and mutations within the sequences and where they created, designed, functional, whatever, right? That's what that conversation ended up being largely about. It's about an hour long, and probably 40 minutes of it was about ERVs, give or take, if I remember correctly. SFT was not happy with Dr. Jackson's position. He actually, funny story, he wrote a long Facebook post on it. I didn't realize it was him. And I was like, hey, you want to come talk about it? And then he got back. I was like, oh, I should have known. I should have looked at the profile before I sent the message. So SFT was not happy with Dr. Jackson, because Dr. Jackson said, yeah, they're from viruses. Like, the herbs are derived from viruses. He accepts the mainstream view of like how herbs got there. SFT not happy with that, not having it. So I reached out to SFT to talk, initially not realizing it was him, but I reached out to talk, and he said he was too busy throughout the month of like April and had to read up on herbs before he felt comfortable having that conversation. Now, funny thing happened later on in April. He had a debate about herbs with some, I don't remember who, some random person. I don't know who it was. If you're that random person, I apologize. I just don't remember who it was. I know he had a debate with somebody about herbs. So I guess he wasn't too busy in April to talk about herbs. Just didn't want to talk about them. Someone who's like studied the evolution of viruses professionally. So then this book happened. Okay. Had to do research. Now, I feel like this book is a recent thing. Like, it wasn't in the works for a long time, because when I first reached out, just too busy and had to do research on herbs where I was comfortable with it, and then did the debate, and then the book appears a couple months later. So I feel like I'm a little bit to blame for this book based on my conversation with Dr. Jackson and subsequent responses to it, which means this is kind of karma. Me having to read this book and review it is a little bit of karma there. So that is where I will end this. I thank all of you for watching. I appreciate you. If you haven't already hit like, please do that. I would really appreciate that. If you're not subscribed, if you're watching this and you're not subscribed, hi, welcome. I don't know what you're doing here, but what I do is I talk about young Earth creationists and intelligent design stuff and creation science and show why it's wrong. So thank you all for being here. I hope you enjoyed and found informative my review of the Endogenous Retrovirus Handbook by Donny B, Standing for Truth. It doesn't dismantle the best arguments for common ancestry. It doesn't at all. They need to come up with better models and also have editors for books. Thanks, everybody. Have a great night. That is the end.